All right, so let's start with this. I'm going to teach you how it moves through. So you got to know two things. You've got it, how energy is moving through the ecosystem. You got to understand what a food chain is. Now think of a chain. Every link in the chain is a separate living creature. Okay? And as the energy moves to the links, something weird starts happening with the energy that originally came from the sun. And so a food chain is just one path. Remember? Just one path that's showing how that energy is transferred from one living thing to the next. Well, how does one living thing transfer its energy to another?
It eats it.
It's got to be eaten. That's how it transfers. It's not always the choice thing. You know, deer, they like to run. They don't want to. They want to live. They want to survive. But if they do get eaten, that energy is then transferred to whatever's eating the deer. Okay? And so in this actual food chain, you look, here's producers like plants. They're getting that energy free from the sun, right? 100% they're getting from the sun. Grasshoppers eat the plants. There's a transfer of energy. The mice eat the grasshoppers. There's a transfer of energy. Anytime you see an arrow, that's showing you there's a transfer of energy. The snake likes to eat the mice. Hey, the mouse is going to transfer its energy over. And then at the very tip top, you got a hawk or an eagle or whatever it is. It'll eat the snake. Is there anything that really eats one of those? Not really. If it got caught down below, maybe something would snag it up and eat it, but it's at the very tip top of the food chain. Okay? Remember, something weird is happening to the energy right here as it's moving through the food chain. Now, there are also things called food webs. Okay? Food webs. I'm going to expand this a little bit so you can see it. If you put a bunch of those food chains together, you get food webs. You know, you ever watch a spider make a web? He's got to do it one strand basically at a time. But in ecology and energy, it's going to be one food chain at a time. Now, the picture I showed you, this could be Indiana except for one creature. This could be Indiana except for one creature.
Alligator.
Yeah, you can see the alligator. You guys did know, right, that one time they did find an alligator in the Intercore River by Brook. Have you ever heard of that? I knew the kid that found it. He was from KV. They actually shot him. So somebody must have had an alligator.
It was, right by my house.
Was that by your house?
Told me about it.
And they let it go. But it got to wintertime, it would have died. It couldn't have survived it. But imagine the shock of saying, oh, whoa, dude, look at that. It's an alligator. But yeah, this here is not Indiana. But it could be because we have everything there except for the alligators. Now you can see, look at all the arrows. Remember, arrows show you where the energy's going. If I were to, now I want you to give me a good opinion. I don't care if you're right or wrong. Just don't blurt it out. If I were to say, I take out all the catfish, would this whole food web, do you think it would collapse? Yes or no? Are there other things that they can eat other than the catfish? Probably, right? It's not going to affect it. It will affect it, but it's not going to collapse it. But there's one creature here that if I remove it, it's going to collapse it. Do you know what it is, Karen?
The bottom one?
The bottom one, the worms. How do you tell?
Because that's where every other thing gets its energy out.
Yeah, look at that. You guys do know that we had red worms in Indiana, but we didn't have the long night crawlers. Those were brought over by the Europeans when they settled on the East Coast. And the earthworms, what we call night crawlers, they worked their way west. And if it wasn't for them and the other worms, yeah, if they didn't turn the soil over and like break up all this matter, none of these other things could live. They're a very important link in the chain. In this case, the web. Okay, energy pyramid. Write down energy pyramid. Energy pyramid. Just draw it out rough. You don't even necessarily need to. This here you don't necessarily need. But I want to go through it with you quick because I could ask you 10 questions on the test over just this. And it's easy. If I divide 100 by 10, what do I get? What's 100 divided by 10? 10, right? Well, there's a rule called the rule of tens. What if I divide 10 by 10? 1. What if I divide 1 by 10? 0.1. What if I divide 0.1 by 10? 0.01, right? You already know the rule of tens, because if you can divide 10 into whatever number, that's it. That's called the rule of tens. You need to know that. That's important. That's important. Let me show you how this works. If you look down at the bottom of the pyramid is designed to be wide at the base. Okay, very strong. And then you notice that it goes thin till it gets to the very top and it's a point. Well, if you look at the base is the primary producers. That's all your plants. That's all your plants. You see this 100%? They get 100% of all their energy from the sun. But let's say a grasshopper comes along and it eats the grass. How much of its energy is going to originally have started in the sun? Think rule of tens. You know? What you got? Say it. Say it.
90%?
No.
10.
10. Because remember the rule of tens? Look at this. If I erase it, it's 10%. It's kind of hard to see, but they get 10% of their energy from the sun. That 10% of that original energy came from there. Now let's say a mouse comes along, eats the grasshopper. What's happening? How much energy is it going to get from the sun?
1.
Rule 10. Divide. 1%. You see what's weird is happening to the energy? Remember I said something weird is happening? Look at it. It's getting less and less and less available. Now, let's say a snake comes along, eats the mouse. How much energy is it going to get from that mouse originally? Say it. 0.1. 0.1. And then the apex predator, that means it's at the top, nobody messes with it, nobody eats it. A hawk comes down, eats the snake. How much? 0.01. 0.01. Now, we got a problem. We got energy can't be created and it can't be destroyed. If it were, then we could make stuff appear out of nowhere. We can't do that. You cannot create energy. It can only be transferred. Okay? Now think about this. Where is that energy going? It's being lost. Touch your neck. What do you feel?
Skin.
What about your skin?
It's hot.
It's hot. So guess where all that energy's going? It's being lost. Have you ever been on a bus with a bunch of little kids for a long period of time? What happens to the temperature on the bus? It goes up. They're crazy. That's because it's being lost as heat. It's being lost as heat. Major test question right there. It's being lost in the form of heat. Now, your body, my body, it uses other energy in other ways, but most of it is lost as heat. So from here to here, you got 99.99% is lost as heat. Okay? Test question. Now, you don't have to write this pyramid down, but I want you to look at it. Check that out. Producers. There's way more producers on the planet, so their population is large. But look what happens. As you go up the pyramid, the population gets less and less. Okay, and I'm going to show you about that in a minute. But the energy, same thing. There's a lot of energy available here, not as much available here. So it probably has something to do with each other. Remember, energy is that ability to do work. There's not a lot of it. There can't be a lot of population. Now, here's a real-world example of an energy pyramid. Check it out. Kind of hard to read it. But here's freshwater shrimp. This could be Indiana. Okay, freshwater shrimp. Look at that. It takes 10,000 freshwater shrimp to support 1,000 bleak. You know, a bleak is like a shad. It's like a little fish called a shad. Okay? So it takes 10,000 of these freshwater to support 1,000 of those. Uh-oh, look what's happening to the numbers. Why isn't it 10,000, 10,000, 10,000, 10,000 all the way up? What's there not available up here? to this guy that there is here. Ability to do work starts with an E. Energy, right? Remember, it's all about it. And then perch, if you've ever fished for perch, they're kind of a cool, tasty fish. It'll take 1,000 bleak to support 100 perch. Look at that. The rule of tens is in play here. And then northern pike. Look at that. That is a dream catch. That's a dream catch. But it takes 100 perch to support 10 northern pike. And then up here you got an osprey, which there are in Indiana. It's way bigger than the bald eagle. It's probably, its wingspan is probably from my fingertip over here to the end of the stick. It's huge. It's huge. And look what it's carrying. Northern pike. One osprey. It takes 10,000 freshwater shrimp to support it. And the energy is being transferred from one to the next and then lost as heat. That's that simple. That's it. Now, any questions?